Prime numbers. Prime factorization. Prime factorization is all the prime numbers that multiply to get the original number. So let's look at an example to kind of see what this means. So example 1, what is the prime factorization of 16? So 16 is a composite number. It's made up of several prime numbers multiplied together to get that number. So all we're going to do is break down 16 into all its prime numbers. So how we do this is we can call it a factor tree. So we have 16 here. Now, kind of going back to an earlier lesson when we talked about divisibility tests. So what we can start doing is kind of look at, those prime numbers in our divisibility test and kind of see how we can break this down. So 16, we see that it ends in a 6, so we know it's even. So therefore, we can divide it by 2. So it's made up of 2, so 16 divided by 2 is equal to 8. So if we multiply, see these two numbers, it gets the number on top. So it's a factor tree because these two kind of come off of 16, and those are the factors of 16 here. Now, 2 is a prime number, so we're just going to go ahead and circle out. 8, though, is a composite number, so we need to keep going because we need to break it down into the prime numbers where we can't break it down any further. So 8. 8 is also even, so let's break this down into 2 because any even number can be divided by 2. So 8 divided by 2 is equal to 4. So we put the 4 on the right-hand side. And now we have another 2 here. Now, here we have 4. 4 can be broken down into 2 and 2. Because 4 is even, and we know 2 times 2 is equal to 4. So in order to get 16, how we can do this is we can go 2 times 2 times 2 times 2. And that is equal to 16. So the prime factorization is this 2 times 2 times 2 times 2. Now, another way to show this, so is we can write 2, because that's how many there are. That's the number. And then we have 4 copies of this, because we have 1 here, 1 here, 1 here, and 1 here. So we have to have 4 2's multiplied together to get 16. So to show this, rather than writing 4 2's being multiplied together, we can just put 2 to the 4th power. Now, this is called an exponent. It tells us how many copies we have of 2, or how many of the number 2 we have, which in this case we have 4 of them. So we can just show what is the prime factorization of 16? Well, we can just represent it like this, 2 to the 4th power, or we can show it like that as well, 2 times 2 times 2 times 2. They mean the exact same thing. Now, let's look at another example. Example 2. What is the prime factorization of 64? Well, 64. If we look at 64, we notice it ends in a 4. So we know it's even, so we can divide it by 2. Now, maybe we forget what 64 can be divided by 2 in. So we can just do our long division over on the side. So 2 can go into 64 how many times? Well, 2 can go into 6 3 times. So 2 times 3 is 6. We subtract, we get 0. Then we bring down the 4. And now 2 can go into 4 how many times? Well, that's 2 times. So 2 times 2 is 4. We subtract, we get 0. So 2 times 32 is equal to 64. So we put 32 here. Now, we have 32, and this is a prime number, so we'll circle that one. Now we need to break that down into its prime numbers. Well, 32 is also even. So we can break this down even further. So we can put 2 here, and 2 can go into 32 how many times? Well, we can go 32. 2 can go to 32 how many times? So 2 can go to 3 1 times. 2 times 1 is 2. Subtract. We get 1. Bring down the 2. 2 can go to 12 6 times. So we're left with 16. So we put 16 there on the right. We can go ahead and circle that too because it's a prime number. And now we just need to break down 16, which we actually just did in the last example. So we know this can be broken down into then 2 and 8 because 16 can be divided by 2 because it's even again. But 8 is not a prime number, so we need to keep breaking this down. So 8 divided by 2 is then 4. So now we have 4, which that needs to be broken down into 4 divided by 2 is 2. So you can see that this is really similar to the last one, except we have more copies of 2 to multiply. So how many 2's are there? There's 6 2's. So the prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2. Or we can show this as 2 raised to the 6th power. These two things mean the exact same thing. But we like to show it like this way because in math, it's just an easier way to write it if you just have to write this 2 in the 6th rather than writing 2 times 2 times 2 times 2 times 2 times 2. Let's look at another example. Example 3. What is the prime factorization of 55? Well, we can see 55, so we're just going to write it up at the top. Well, 55 actually ends in a 5, so we know it can't actually divide it by 2 because it's not even. So 55 can be broken down into, well, we know it ends in a 5, so we could probably do 5 here as the first prime number to take out. So 55 divided by 5 is equal to 11 because 5 times 11 is equal to 55. If you don't remember, you can always do division because 5 can go into 5 one time. So 5 times 1 is 5. We subtract, we get 0. Bring down the other 5. 5 can go into 5 one time. So 5 times 1 is 5. We subtract that and we get 0. So that's how we get 11 too there. No, we know that 5 is a prime number and 11 is a prime number. So we're actually done. So how we show this is you just have to go 5 times 11. And this is the prime factorization of 55. It only has 2 prime numbers multiplied together, which is 5 and 11. So this is the answer. Let's do another example.